lesson, you're going to learn how to use the properties of exponents. The standard we're working on is MGSE 8EE1. Know and apply the properties of integer exponents to generate equivalent numerical expressions. Terms to know. Exponential form is a number that has an exponent and a base. An exponent tells you how many times to use the base as a factor. For example, 3 to the 4th power, your 3 is your base, your 4 is your exponent, and that means 3 times itself 4 times. Properties of powers. The first one is product of powers. When you multiply two numbers with the same base, add the exponent. For example, 8 to the 2nd power times 8 to the 7th power. What you're really doing is keeping the base and adding the exponent. So really that is 8 to the 9th power. Quotient of powers. When you divide two numbers with the same base, subtract the exponents. For example, 3 to the 10th power divided by 3 to the 2nd power. The base stays the same, and you subtract the two exponents. That becomes 3 to the 8th power. Power of a power. To raise a power to a power, multiply the exponents. For example, 6 to the 4th power, and with the 5th power on the outside, what that really is, 6 is 4 times 5. Power of 0. Any non-zero number raised to the power of 0 is always equivalent to 1. So I can go 6 to the power of 0, and that will be equivalent to 1. Power of a product. To find a power of a product, find the power of each factor and multiply. For example, in this problem, 3 times 2 with an exponent of 3 on the outside, I distribute that exponent to both numbers in the parentheses. And power of a quotient, same thing applies. You distribute the exponent to both numbers in the parentheses. Product of powers. To multiply exponential expressions with the same bases, add the exponents. 5 to the 3rd power times 5 to the 2nd power is really 5 to the power of 3 plus 2, which is 5 to the power of 5. Why this works? 5 times 5 times 5 times 5 times 5 is the same thing as 5 to the 5th power. This is just an easier way of doing it. Power of a power. Distribute the 3 just to the exponent, and you have 3 to the 6th power. Quotient of powers. This is just like what you do with product of powers. The only difference is when you are dividing with exponents, you subtract the exponents. For example, 4 to the 5th power divided by 4 to the 3rd power, subtract the 2, and that becomes 4 to the 2nd power. Now, you can always check your work and go 4 to the 5th power divided by 4 to the 3rd power, and you should get 16. Product of a power. I have 9x in the parentheses, and all of that raised to the 3rd power. That 3, that exponent goes to the 9 and the x, and my answer would be 729x to the 3rd power. Power of a quotient. Same type of problem when you're dealing with multiplication. Same concept. Distribute the 3 to both numbers. And that becomes 3 to the 3rd power divided by 4 to the 3rd power, and you get 27 divided by 64. Okay? What is 4 to the 3rd power in standard form? That would be 4 times 4 times 4. So multiply the base by itself the number of times shown by the exponent, and then solve. A negative exponent. A base raised to a negative exponent is equal to the reciprocal. For example, 4 to the negative 2 power equals 1 divided by 4 times 4. So really what this is 4 to the 2nd power is 16, but since that is a negative, that becomes 1 over 16. I can do that with any of them. So like 3 to the negative 3 power. Well, I know 3 to the 3rd power is 27, so that becomes 1 over 27. What is 8 to the negative 3rd power? and I get 1 over 512. As you can tell, that doesn't make it a negative fraction. That just means you are flipping, getting the reciprocal of 8 to the 3rd power. 25 to the power to the 0 power is written like that. And remember, the property states 25 to the 0 power is always equivalent to 1. Now, let's do a few. 7 to the 6th power times 7 to the negative 4. So what that really becomes is 7 to the 6th plus 7 to the negative 4. So you're adding these two guys. And that really becomes 7 to the 2nd power, which is 49.